Hello everyone, welcome back to another remote sensing lecture video. And in this lecture video I want to talk about the issues with overall accuracy. Right, if you remember in the previous videos we talked about this idea of overall accuracy being sort of the overall measure of the model. We talked about user's accuracy, which was how accurate the existing data is, right? How accurate the map we've made is. And producer's accuracy, which is how accurately the model would classify new data. So my hope is that in this video, we'll sort of get a better understanding of why we need each of those numbers and really what is the biggest weakness in terms of overall accuracy and why we're going to talk about something called kappa in the next video. So what I want to do is I want to draw your attention to two different classification tables or error matrices. Okay, right? On the left one right here, we have water being very poorly classified, right? It has only 1 out of 31 correctly classified. So its producer's accuracy is 0.03. So it's not very good, right? But if we look at forest, urban, and soil, right? Forest, urban, and soil have producer's accuracies of 100, which means that the algorithm perfectly classified all three of these classes. Right? But what I want you to look at here is this column summary, right? This is the total number in each column. Right? We had just as many water, actually we had more water validation data than the other three classes combined. So water here was a very large class relative to the others. And so what happened here was because water was such a large class relative to the others, even though the other three classes did really well in terms of their classification, right? The very poor performance of this one class brought down the overall accuracy. Okay? Let that sink in for a minute, right? We're going to formalize this into a little bit more of a summary statement in a second. But again, just look what the impact was of having this one class with a lot of observations pull down this entire model, even though the other three classes did really well. The overall accuracy was really low. Okay? So let's go ahead and look at the opposite. Right? So in this case, right, we had one class with a lot of observations pull down the model. Now let's look over here, where we have the other three classes, right, 7, 5, and 4 observations respectively. Right, terrible producer's accuracy, terrible user's accuracy. Right, but in this case, right, water actually has a lot of observations, right? Again, it has almost 3 times the number of observations as the other three classes. And it did really well, right? Producer's accuracy of 88%, user's accuracy of 100. So again, right, water, in this case, water did really, really well. And because water did well and it had so many observations, right, our validation data had a lot of water, right, our overall accuracy, although still not great, is much higher than it probably should have been. Okay? So let that sink in for a second. Right. Over here, a class with a lot of observations did poorly. It dragged down the accuracy. Over here, right, this class had a lot of observations, did well. It actually brought the accuracy up. So let's formalize that into like a one sentence statement, right? The issue with overall accuracy, right? The number one issue with overall accuracy is that it's highly sensitive right? Highly sensitive to it's highly sensitive to the number of observations in each class. And this is especially true when you have one class with especially true when most of the observations occur in one class. when most observations occur in one class. And specifically what I mean here is when we talk about feeding in validation data. If you have a lot of your validation data representing one class, right, you're going to make an overall accuracy that is highly sensitive to that class at the expense of the other ones, right? And that's what we saw here, where it pulled the model down, and that's what we saw here, where it actually pulled the model up. So again, the issue with overall accuracy is it's very sensitive to the number of observations in each class, especially when you have a sort of strong disparity between the number of observations in one class versus the others, or maybe in two classes, right? So again, you might argue, well, try and make your classes even, and that's a very good idea, right? You should try to make the number of observations in your classes pretty even. But sometimes you just can't do that, right? Sometimes you're getting validation data from other people, and you have to do with what you have. And overall accuracy might be negatively influenced in situations like the ones I've described. Hopefully that makes sense. Again, to recap, overall accuracy is sensitive to scenarios when you have a lot of observations in one class relative to the others. The overall accuracy will be very sensitive to changes in that class. So hopefully that makes sense. And as always, please reach out. Thank you.